Alright, go.
Alright, this your boy Tyler. We're doing the law of conservation of momentum. It's your boy me, AJ, Lewis, and we're going to do a project on this. So yeah.
The law of conservation of momentum. Basically, what that is for a collision between two objects, object 1 and 2, in an isolated system, the total momentum of the two objects after the collision is that the momentum that is lost in the first object when it hits the second object is equal to that's gained by the object that's hit. So basically, an isolated system that's speaking of is just something where no other forces are acting on it, no friction, gravity, just anything else that can make the experiment different than what it really should be. And so what we're going to show in this, or as best as we can, is we've got a board that we're going to use. We're going to put the blue car starting at 120 centimeters, and we're going to put the green car starting at 0. And basically what we're going to do is we're going to have AJ push the green car into the blue car, and using the go motion, we're going to, and this computer logged on to Logger Pro, we're going to see how the momentum and the velocity and the position time changes all the way through when it hits the car. And then on using this go motion sensor and that Logger Pro, we're going to see how the time, position, and average velocity is throughout the entire process for that. Alright, so for our lab report, or our lab project part, we're going to take one motion sensor that's plugged into this computer right here and put it about 30 centimeters away from our two buggies. And what we're going to do is we're going to weigh down each buggy. This one's going to have 100 grams or 1,000 grams or 1 kilogram on it, and this one's going to fluctuate based on what trial we're on. And basically what we're going to do is collide the two together, and the motion sensor is going to detect how much velocity and time and all that, and it's going to put it in the computer. And then here, AJ, show the computer. And basically it's going to show us a graph like this, and it's going to show us the minimum, maximum velocity, and all the peaks and stuff. And then we're going to put it on this graph that shows the, or this table, that shows the kilograms of the one object, and then the both objects combined, and the momentum with the velocities.
Go.
Yeah. Good?
Yeah.
Okay, let's start with the footage.
Just go. Just go. Go.
Okay, so this is going to take one of the collage cars. So if AJ or me will push the button, then we're going to collect that. And I'm going to start these cars. Okay, so the cars collided, so I'm going to highlight the peak of the graph.
All the way over. You gotta highlight from here to here.
Okay, Mr. Genius. Okay, that's that. Okay, so the maximum velocity and the minimum velocity.
Drake, come here, man, come here. Drake, what were we talking about earlier, Drake? This is trial 1. Drake, you have to enunciate, Drake. Let's do it again. Do it, AJ, come back. Do it again. Do it again real quick. Alright, set it back up.
Okay, this is
Set it back
trial
up
1.
first. Drake, set it back up first. Set it up. There you go. Alright, run it back.
Let me go.
Here we go.
Alright, this is trial 1. This is the oh Lord. Alright, here's the maximum velocity and the minimum velocity of the collision. And this is the chart that we did for the collision. And that's about all.
Alright, so this is trial number 5. We added weight on the blue car because it was later in the trials. And now I'm just gonna collide them together. So here's our graph. We highlight the peak of the graph, and the min is 0.0006717, and the max is 1.762.
All right, so this is gonna be our 10th and final trial. So the green car, we still have the same weight. We still have 1 kilogram on it. And now for the blue car, we have 2.5 kilograms on it. So let's see how this works. Hit it. All right, so once again, we're gonna highlight that graph and find the min and max velocity. All right, and so we're gonna go more in depth with our data here. So for this one, we had 2.5 kilograms, which is on our first car.
He's not in our group.
And then for this is the velocity. This is the maximum velocity that we found using the peak of our graph from the motion sensor. And then this is the momentum, which we calculated by using the weight, or the mass of the object divided by the velocity of the object. And for this one, it was 2.72. And then the MC, that's the mass combined, the mass of both the blue and the green car, and that was 3.50. And then the VC column, that's the velocity of the combined two cars, and that's going to be the minimum on that, the smallest point on the peak of the graph. And then for our momentum, once again, that's going to be our mass divided by our velocity, and for this one, we got 56.72.
There we go. Oh, so, well, here I'm just talking about how the data might be a little off because of the forces that act on the cars, like gravity and friction. We don't live in a perfect environment where friction is not there, and then the gravity isn't always pulling on the car, so.
All right, so this is going to be our, we're going to do a little real life test here. This is AJ. Here's Drake. They're going to be like our cars from our experiment, and we're going to see what happens when they collide. Let's see what kind of momentum occurs. Here we go, Drake. Here's AJ. Here we go. Here we go. Here we go. We got the momentum going. And that is law of conservation of momentum.